Normandy, June 1944. A German Oberleutnant from the 275th Infantry Division has been in his command post since before first light. The position is good. The way positions in the Bocage were always good at first glance and always lethal to hold once the fighting started. He has telephone lines running back to battalion, lines that his communications sergeant checked at last light and checked again at first light, because lines in the Bocage lasted until the first artillery concentration, and sometimes less. He has two messengers, the melder, young soldiers who know the paths between the hedgerows well enough to run them in the dark, who have memorized the landmarks by feel because there are no landmarks in the Bocage, only walls of vegetation that all look the same at 3 in the morning. He has a clear picture of his front, at least as clear as any picture in the Bocage ever was, which is to say he knows where his own men are, he has estimated where the Americans probably are, and he has set his machine guns to cover the 3 lanes through which the Americans will have to come if they're going to come at all. 2 platoons forward, 1 back. The heavy machine gun registered on the gate at the far end of the lower field. The mortar section pre-plotted on the road junction, 200 yards to the west. The observer with the forward platoon has a telephone line back to the mortar position and has already walked the gun onto 3 reference points. He has done everything a German officer is trained to do. He waits. If this story is pulling you in, take a second to hit the like button and subscribe, and drop a comment telling me where in the world you are watching from. It means a great deal to know who is listening. The American company makes contact with his left forward platoon at 9:30 in the morning. It is a routine opening, the kind of contact the Bocage produced a dozen times a day across the whole front. Rifle fire from the far side of the hedge. A Browning automatic rifle working in short bursts. The distinctive, slow mechanical rhythm of the American automatic rifle that every German who had fought in Normandy for more than a week could identify by sound. The left platoon goes to ground and returns fire. The Oberleutnant hears the exchange from his command post and begins calculating. The Americans are the hedge. They will probe. They will look for the gap. His left platoon will hold them in the hedge while he assesses whether this is the main effort or a diversion. He considers sending a runner to the battalion to request artillery on the far side of the hedge where the Americans must be assembling, but he decides to wait. This is correct German doctrine. You do not call for artillery on a position you cannot confirm. You develop the situation. You find the target. Then you call the fire. For minutes after the first exchange of fire, artillery rounds begin falling on his right forward platoon. The right platoon has not fired a shot. It has not been engaged. No American has come near it. The shells fall with the precision of a pre-plotted fire mission, because that is exactly what they are, a fire mission called by an American forward observer who studied the map the night before, identified the most probable position for a German reserve or right flank element based on the available terrain, registered an artillery reference point in that area during the pre-dawn preparation phase, and transmitted the adjusted mission within seconds of the contact on the left flank confirming his assessment. The right platoon is not a surprise to the American artillery. It is a prediction that has just been confirmed by events. By the time the Oberleutnant processes the sound of rounds falling on his right and send a runner forward to assess the damage, the right platoon is combat ineffective. The runner returns while the left platoon is still holding its fight in the hedge, and the mortar section is trying to lay smoke without a clear target. The Oberleutnant sends a second runner to the battalion, requesting permission to pull the remnants of the right platoon back and requesting artillery support for the left sector. The runner does not return for 11 minutes. By the time the reply arrives, permission granted and reinforcements promised, the situation has moved past the reply in every meaningful sense. The Oberleutnant will describe all of this 3 days later to an American intelligence officer in a tent 6 miles to the rear, a tent that smells of damp canvas and coffee, and the particular flatness of a headquarters removed from the fighting. He will tell the interrogators that the speed of what happened to his right platoon was, in the word the translator will render into English, incomprehensible. He had done everything correctly. His positions were prepared. His communication system was functioning as designed. His fire plan was ready to execute. And yet a flank he had not engaged was destroyed before he had generated a request for the support that might have saved it. From inside the framework of how the German army understood communication and fire support, this speed was not possible. That is the verdict his own experience produced. In that verdict, repeated in dozens of interrogation reports across the summer and autumn of 1944, points toward a structural gap between the two armies that had nothing to do with courage or tactical intelligence. It had been built over 15 years, quietly, in places most people who study the war have never heard of, before the war began. If this story is pulling you in, take a second to hit the like button and subscribe, and drop a comment telling me where in the world you're watching from. It means a great deal to know who is listening. The German infantry of 1944 was, by almost any measurement taken at the level of the individual soldier and the small unit, among the finest fighting organizations in the world. That sentence is not a polite historical concession. It is the consistent finding of Allied after-action reviews, of the post-war analysis conducted by the American Army's own historical program, and of historians who have spent careers studying the campaign records from both sides of the line. The German platoon in Normandy was built around automatic weapons in a way the Allied platoon was not. The MG-42, the machine gun that anchored every German squad, produced a cyclic rate of approximately 1,200 rounds per minute from a weapon that weighed 25 pounds and could be carried in place by a single soldier in under a minute. The standard Allied light machine gun of the period, the British Bren and the American Browning automatic rifle, had cyclic rates between 500 and 600 rounds per minute, less than half the German figure. A single German squad positioned in a hedgerow could generate a volume of suppressive fire that an entire Allied section struggled to match. The non-commissioned officers who led those squads have been trained in a system that valued tactical judgment at the lowest level. The German squad leader in 1944 was typically a veteran of 2 or 3 previous campaigns, shaped by a military culture that treated initiative as a professional virtue and passivity as a professional failure. He was not waiting for orders to tell him which way to face his gun. He was reading the ground, picking the position that covered the most likely approach, and occupying it before his officer had finished issuing the company order. The instinct for reverse slope defense, for interlocking fields of fire, for the enfilading position that turned a frontal assault into a slaughter from the flank, had been drilled into German infantry training since the 1930s and refined through years of combat on 3 continents. These skills were not theoretical. They had been tested in Poland, in France, in the Soviet Union, in North Africa, and in Italy, in 4 years of continuous warfare, and the men who carried them to Normandy in June of '44 were not men who had learned them from manuals. They had learned them from experience, from the specific and unforgiving education of surviving actions in which less capable men had died. The Bocage terrain of Normandy seemed constructed to reward exactly these qualities. The Norman hedgerows were not decorative agricultural features. They were medieval earthworks, banks of compacted earth 4 to 6 feet high, topped with centuries of vegetation growth that had produced root systems deep enough to stop a Sherman tank in its tracks. The sunken lanes between the banks funneled attacking infantry into kill zones that any German non-commissioned officer could identify at a glance. Every gate was a natural choke point. Every ridge of high ground looked down into the lane beyond it. The landscape had been fortified by 1,000 years of farming, and the German infantry occupied it with the confidence of men trained to see defensive advantage in exactly this kind of terrain. American after-action reports from the first weeks of the campaign return again and again to the same observation. German positions were consistently hard to identify until they fired, consistently well-sited to create mutual support between adjacent positions, consistently able to force the attacking infantry to ground before the assault had reached any tactically significant depth. The men who wrote those reports were professional soldiers. Their assessments were not generous. When they said the German positions were good, they meant it in the precise sense that mattered. The positions were costing lives to take. Against the British Army, the German defensive system in the Bocage performed with brutal efficiency. The British way of fighting in Normandy was deliberate, set-piece, built around carefully prepared fire plans and methodical advances onto confirmed objectives. The British infantry section had the Bren gun and the Lee Enfield bolt-action rifle, a combination that worked well against a target that could be identified and fixed in place. The standard British engagement sequence ran through human eyes, finding an enemy, then suppression, then fire and movement to close with and destroy the position. When German camouflage and the terrain made the enemy invisible until he fired, The British sequence stalled at the first step. They went aground and called for support, and while they waited for the support to arrive, the German mortar section, already registered on the approach line, dropped rounds on the ground the British were lying on. The mortar section did not need to see the British soldiers. It had plotted the approach routes before the battle began. The approach routes were fixed by the terrain. The British soldiers, trained to advance along the available routes, were walking into pre-planned fires every time they moved. Against the American army, something different happened, and the German prisoners who described it in interrogation rooms across the summer and autumn were genuinely unable to explain what the difference was. The Americans were cautious, they said. The Americans did not press their infantry forward with the aggression that German doctrine had taught them to expect and to exploit. The Americans went to ground quickly, called for support, and waited. From a German foxhole, the American attack sometimes looked like hesitation. But the artillery that followed the American infantry did not hesitate, and it fell on positions the American infantry had not reached, and it came faster than any artillery the German infantry had encountered in any previous theater. The German sergeant who watched his mortar section destroyed before it had fired a single round, the Oberleutnant whose right platoon ceased to exist 4 minutes after the left platoon made first contact, were both experiencing the same phenomenon. They had no doctrinal category in which to place it. The category they were missing lived in the relationship between two pieces of equipment that the American army had been quietly developing and distributing for 3 years before the invasion of France. The first was a 5-pound radio. The second was a system for processing what that radio reported. To understand why both were necessary, and why the German army had neither in the right configuration, you have to go back to Fort Sill, Oklahoma, in the years between the two world wars. The Field Artillery School at Fort Sill was, in the 1930s, a modestly funded institution working on what appeared to be a purely technical problem. If you had multiple artillery batteries spread across miles of terrain, each capable of firing on a target called by a single forward observer, how did you get all of them to engage simultaneously rather than sequentially? The sequential solution required the observer to adjust each battery individually, a process that could consume half an hour and gave the target ample time to move or to reinforce. The simultaneous solution required a centralized computation node that received the observer's target data, worked out the firing data for every battery in range at the same time, and transmitted the results to all of them in a single coordinated message. The Fire Direction Center that Fort Sill developed in the early 1930s, under the direction of Carlos Brewer and his instructors, was that node. It was initially a procedure as much as a place, a way of organizing the information flow between the observer and the guns so that one call produced multiple simultaneous responses. The time-on-target technique that grew from this doctrine coordinated the varying flight times of shells from batteries at different distances so that all rounds arrived at the target at the same moment, regardless of the different ranges and trajectories involved. The practical effect was that a single request from a single observer could deliver the mass fire of an entire artillery brigade within the time that a single battery had previously required to adjust and fire. The Fire Direction Center compressed artillery response time from the 30-plus minutes that sequential adjustment required to something closer to 5 to 7 minutes under normal combat conditions. But that compression began only from the moment the observer transmitted his first call. If the observer was at the platoon level in a hedgerow in Normandy, and his communication path ran by runner to the company, by telephone from the company to the battalion, and by radio relay from the battalion to the Fire Direction Center, the bottleneck was enormous. The bottleneck was not in the center's calculation or in the gun's firing time. It was in the chain of human relays between the man who saw the target and the system that could act on what he saw. Every link in that chain added minutes. Every runner, every telephone connection, every radio relay added minutes. The observer had to call fast, directly, without the call passing through multiple human hands on its way to the guns, which meant the observer had to have a radio. And the radio had to go where the observer went, which was with the forward infantry, which meant it had to be small enough and light enough and robust enough for an infantryman to carry into action. Donald Mitchell, chief engineer at the Galvin Manufacturing Corporation in Chicago, had understood this before the Army had fully articulated it as a requirement. He had watched a National Guard training exercise at some point before 1940 and observed something that the military had been quietly living with without building around. When the exercise became confused and the vehicles bogged down, the radio sets mounted in the vehicles were abandoned with the vehicles. The soldiers moved. The radios stayed in the mud. Mitchell went back to his office and wrote down the requirement in a form that the Signal Corps eventually acted on. The radio has to follow man in combat. Not follow man in the sense of being light enough for a vehicle. Follow man in the sense of being carried by a single soldier with both hands occupied, in rain, in mud, in the dark, under fire, and still transmit when the soldier needed it. The set Mitchell's team produced was designated the SCR 536 by the Army Signal Corps. It weighed approximately 5 pounds. A 40-inch retractable antenna at the top of the case served as its power switch, extending to activate and retracting to cut power. Dry cell batteries provided roughly a day of normal use, a figure that fell in cold weather, in wet conditions, and as the batteries aged. Voice range over open ground was approximately 1 mile. A single frequency channel, set by crystals installed at the factory or the maintenance depot, could not be changed in the field. 5 vacuum tubes in a case that was water-resistant in design, but not always in practice. The Signal Corps reviewed the prototype and was not immediately enthusiastic. 1 mile was a short tactical distance. The fixed channel severely limited the set's usefulness in complex operations where multiple nets had to operate simultaneously. The battery situation required a separate supply chain. The set had, by the frank account of one of the Signal Corps officers who managed its early deployment, no end of problems in operational use. But it entered mass production in July of 1941, and by the time the Army was fighting in Sicily in the summer of 1943, the allocation had been set as standard: 6 SCR 536s per rifle company, 1 for each of the 3 rifle platoon headquarters, 2 for the weapons platoon, and 1 for the company commander. By the end of the war, Motorola, as the Galvin Manufacturing Corporation had been renamed, had manufactured approximately 130,000 units. Other contractors added to that total. When German signals officers examined captured CR 536 sets in Sicily in 1943, the reaction recorded in Allied intelligence summaries was one of recognition combined with something the intelligence officers described as professional unease. The technology itself was not surprising. What struck the German analysts was the distribution. The United States was the only nation in the war that had issued hand-carried radios to the rifle platoon as standard table of equipment items. Not special equipment allocated to elite units. Not a trial program in selective formations. Every American rifle platoon in every infantry division in the Army had one. The German analysis correctly identified the primary function: coordination between the platoon leader and his company commander over short distances. What the analysis did not fully account for was the fire support chain that ran through that link, because in the German fire support chain the platoon was non-node. The German platoon leader received fire support through his chain of command. He did not originate fire support requests directly to the artillery net. That was not what German platoon leaders did. The set looked like a local coordination tool. From inside the German doctrinal framework, it was one. From inside the American doctrinal framework, it was the forward end of the entire fire support architecture. Alongside the SCR 536, the Signal Corps was fielding a companion set that completed the architecture the Fort Sill doctrine required. The SCR 300 was a backpack radio, designed by a team at Galvin that included engineer Daniel Noble. Noble had insisted on using frequency modulation rather than amplitude modulation over initial Army preference for AM technology, and his argument rested on a single field reality that the laboratory testing confirmed. FM transmissions were effectively immune to the electromagnetic interference produced by artillery fire, vehicle engines, and the general industrial noise of a modern battlefield in a way that AM transmissions were not. German infantry radios of the period used AM. American infantry radios used FM. Every time a heavy artillery preparation began, every time the battlefield was at its loudest and its most electromagnetically chaotic, American radio communication degraded less than German radio communication. In the moments when fire was heaviest, when communication was most critical and most difficult, the difference was most pronounced. One American general, assessing the winter campaign of 44 to 45, stated that the SCR 300 was the most useful radio in the Battle of the Bulge. The precise meaning of that assessment is that it worked when everything else was firing. The SCR-300 weighed approximately 35 pounds and was carried as a backpack by a dedicated radio operator. It operated in the 40 to 48 MHz frequency band, channelized across 41 discrete frequencies, with a voice range in the field of up to 3 miles under good conditions. Motorola and other manufacturers produced approximately 50,000 units before the war ended. This set connected the Rifle Company command post to the Battalion Fire Direction Center, and the forward observer attached to each rifle company carried one. When the observer called a fire mission, the call went from his SCR-300 directly into the fire direction net. The center processed the target data. The firing solution went simultaneously to every battery in range. Under normal conditions in an established area, the first shells arrived within 5 to 7 minutes of the observer's initial transmission. The German artillery request cycle, when everything in the German system functioned without interruption, ran to 15 or 20 minutes from the moment an infantry unit identified a target and generated a request. When the telephone wire was cut, when the runner was wounded in the lane, when the battalion radio net was congested with traffic from multiple simultaneous engagements up and down the front, it ran longer. In the Bocage of Normandy in the summer of '44, where engagements were simultaneous across the whole front every day, and where artillery concentrations were regularly cutting the telephone lines that ran between every company and battalion, congestion was the normal condition rather than the exception. The torn Fu D2 at the company level was competing for net time with every other company in the battalion, and the battalion radio was competing with every other battalion in the regiment. The American system had been designed to handle this traffic volume. The Fire Direction Center accepted calls from multiple observers simultaneously and prioritized them. The architecture had been built around the assumption that all observers would want to call at the same time because all engagements happen at the same time, and the architecture had been designed to accommodate that reality rather than to assume a calmer, more sequential battlefield that never existed in practice. The interrogation reports compiled by 1st Army G2 through the summer of 1944, distributed through the Army's Combat Lessons program, record the German prisoners' description of American artillery with a consistency that amounts to a form of testimony. The speed is the dominant note in almost every account. The ability of the American artillery to hit positions the German infantry believed were unobserved is the second note, repeated in report after report, with a persistence that suggests it was not an isolated tactical anomaly, but a systemic feature of what the German infantry was experiencing across the entire front. The prisoners were not wrong in their technical assessment that the positions were unobserved in the direct vision sense. The American forward observer, who called fire on the German right platoon 4 minutes after first contact on the left, was not necessarily looking at the right platoon when he called. He was acting on a map study, on an assessment of how the terrain constrained the German defensive positions, on a prediction about where the second-line element would be given the ground available and the geometry of the likely American approach. He was calling fire on a probability, a location that the terrain and the doctrine made almost certain to contain German troops, and the radio let him act on that probability immediately, without running the call through a command cycle, without waiting for visual confirmation, without obtaining permission from anyone above him in the chain. He had the radio. He had the fire direction net. He had the observer's prerogative to call and adjust. He used it. This behavior was incomprehensible to the German infantry from inside their training for the specific reason that German doctrine held that artillery fire on an unconfirmed target required a level of authorization that the forward platoon did not possess and could not obtain quickly. The German platoon leader had direct access to his mortar section through the telephone observer, and he could call mortar fire on his own authority. For artillery, the request traveled upward. The company commander assessed the request against the larger situation and the availability of artillery support. The battalion coordinated with the regiment. The decision to fire traveled back down. This chain existed because German doctrine, rationally, did not want every junior officer independently calling down heavy artillery fire on his own judgment, creating conflicts between adjacent units, wasting ammunition on unconfirmed targets, and disrupting the fire plans of higher commanders who held a broader picture of the battle. It was a sensible system. It had worked. It was not designed for an opponent whose platoon leader operated as an independent fire control node with direct access to the artillery net, because no opponent had previously been built that way. By the autumn of 1944, as the Allied armies fought toward the German border through the Siegfried Line and the approaches to the Rhine, the communication gap between the two armies had widened in ways that the first weeks of the Normandy campaign had not fully shown. Allied strategic bombing was hitting German signals production with increasing effectiveness. German raw materials for electronics manufacturing were being rationed against competing priorities in an industrial economy under severe pressure from multiple directions simultaneously. Wehrmacht infantry units in the field were reporting shortages of replacement batteries for their radio sets in quantities that could not be made up from rear area stocks, shortages of the frequency crystals that controlled channel selection in the Torn series, shortages of spare vacuum tubes. Field communications were improvising with components cannibalized from captured civilian telephone exchanges, with motorcycle messengers extending the range of the running melder, with any expedient the Nachrichtentruppen could find to maintain the connections the tactical situation required. The American Signal Corps, in the same period, was refining its procedures based on 2 years of combat experience, training replacement radio operators before they reached the theater, pre-positioning spare batteries and crystal sets in the supply chain, and integrating the radio architecture with fire direction procedures in ways that continued to push response times toward their practical lower limits. The gap that had been a doctrinal and organizational asymmetry in Sicily in 1943 had become, by the Rhine crossing in March of 45, a material reality as well. If this is the kind of history you want more of, subscribe and turn on notifications. There is far more in the record still to cover. Your support is what keeps these stories coming. Erwin Rommel wrote to the German High Command in the weeks before he was wounded by Allied air attack in July of 44. In the careful military prose of a commander summarizing a situation without self-pity, that American artillery superiority and the density of American ammunition supply were the dominant material factors shaping the campaign. He understood what the American artillery was doing in the specific sense that he could describe its effects accurately. His letter named the weight of fire and the volume of supply as the proximate causes. What the letter did not trace to its organizational root was the radio architecture that made the fire delivery system function at the speed it functioned. The observation belonged to a different level of technical analysis than a letter between commanders addressed. But the mechanism was there in every engagement report that reached him. The fire came fast. It came before the German chain had processed the request, and it came on positions that should not yet have been known to the enemy. To replicate the American system, the German army in Normandy in the summer of 44 would have needed to distribute several thousand additional portable radios to its rifle platoons, retrain every platoon leader as a fire control operator capable of working directly with the artillery net, redesign fire direction procedures at the artillery level to accept and process calls from sources currently outside the net, and sustain the equipment and its battery supply in a theater where strategic bombing was already making every component of the logistics chain difficult. It would have needed the industrial capacity to manufacture the equipment and the fuel to move the supply. By the summer of 44, Germany had none of these margins available. The Wehrmacht's signals production was being rationed against aviation and armor, and the infantry received what was left. The American radio distribution that had begun as a doctrinal decision in the 1930s was, by 1944, also an industrial fact that German manufacturing could not approach. The Oberleutnant, with the bandaged arm and the cold coffee, had done his job correctly. His positions were prepared. His men were trained. His fire plan was sound. His communication system was functioning within the parameters it had been designed to function within. What he had not been given, and what his army had not built into its structure, was a way to reach back through the artillery chain fast enough to answer a call that had already been made before he knew there was a call to make. His runners were good soldiers doing precisely what they had been trained to do. They were simply running, as runners always had, through a battlefield where the fastest link in the other side's fire support chain was a radio signal traveling at the speed of light to a computation center that was already calculating the trajectory of the rounds that would arrive before the runner reached the battalion command post. He told the interrogators that the speed was incomprehensible. He was right. From inside what he had been taught, from inside the framework of how the German army understood communication and command, and the relationship between observation and fire, it was incomprehensible. The explanation lives not in the dramatic record of famous battles, but in the organizational decisions that preceded them, in the classrooms at Fort Sill, and in the engineering offices of Galvin Manufacturing, in the Signal Corps procurement tables, and the factory floors in Chicago, where armies are built before they are used. The German army had built instruments of fire and movement that were the finest in the world. The American Fire Direction Center was not immune to this problem, but it had been designed with more redundant links, more alternative communication paths, and a more explicit set of standardized procedures that reduced the dependence on any single individual's judgment or presence. What the radio did for the American system was not simply speed it up. The radio was the physical expression of a doctrinal decision that the man farthest forward was the most important node in the fire support chain. Everything in the American fire support architecture existed to serve the forward observer's call. The Fire Direction Center was his processing system. The artillery batteries were his delivery mechanism. The battalion and regiment communications were the infrastructure that kept his call connected to the processing system. None of these elements had independent value without the forward observer's call. The call was the origin of the system's output, and the call required a radio, because the man who made the call was not at a telephone, not at a headquarters, not at a place where a runner could reliably reach him on a useful time scale. He was at the front edge of the battle, because that was the only position from which he could see what the Fire Direction Center needed him to see. There is a document from the Signal Corps Historical Program, compiled from field reports and unit histories in the years immediately after the war, that describes the experience of SER 300 operators attached to infantry companies during the Normandy campaign. It notes, with the practical candor of an official history written by people who were there, that the sets were not easy to use in the Bocage. The FM frequency that made the sets resistant to artillery interference also made them sensitive to the terrain, and the thick earthen banks of the hedgerows absorbed and deflected radio signals in ways that the laboratory testing had not fully anticipated. Operators learned to position themselves on the slightly elevated banks rather than in the sunken lanes to get reliable transmission. They learned that a few feet of elevation made the difference between a clear call and static. They improvised antenna extensions from wire strip from German field telephone cable when the standard antenna proved inadequate in heavily enclosed terrain. They developed techniques through trial and error in the middle of actual engagements that were passed from unit to unit through the informal networks that experienced soldiers build in every theater of war. None of this improvisation was extraordinary. It was the normal adaptation of any equipment to field conditions that laboratory testing cannot fully simulate. What it demonstrates is that the American radio architecture in the Bocage was not a perfectly functioning machine that operated identically to its manual specifications. It was a partially improvised, continuously adapted system operated by men who were learning its field behavior at the same time they were using it to call artillery fire. The 5 to 7 minute response time was an average that hit a range of actual times from under 3 minutes in situations where the observer had good communication and a well-registered target, to 15 or 20 minutes in situations where the radio was struggling with terrain and the artillery net was congested. The German prisoners who described the American artillery as arriving in 4 minutes were describing the good cases. The cases where the radio failed, where the call took longer, where the artillery arrived too late or not at all, are recorded in American after-action reports with equal honesty. The system was not perfect. It was better than the alternative, and better by a margin that was decisive in the aggregate. The aggregate is where the story is told, not in any single engagement, not in any single observer's call, but in the pattern across hundreds of engagements over the summer of '44, in which the American artillery response consistently arrived within the window, in which it could still influence the outcome of the engagement, and the German artillery support consistently arrived outside that window, or not at all. The German prisoner who could not explain how the Americans knew where his mortar section was before it had fired a shot was experiencing one instance of a pattern. His battalion commander, who had been receiving reports of similar instances from every company in the battalion for 6 weeks, understood that the pattern existed without being able to explain the mechanism. Rommel, who had been receiving reports from every battalion in his army group, understood that the pattern was shaping the campaign without being able to see the specific technical decision that had produced it. The specific technical decision was the allocation table. 6 SCR 536s per rifle company. 1 SCR 300 per forward observer team per company. A fire direction center at each artillery battalion trained, and equipped to receive calls from any observer in the net and to produce firing data within seconds. These three elements, working together, were the mechanism. They had been assembled from components developed over 15 years by people at Fort Sill and Galvin Manufacturing and the Signal Corps Procurement Office who did not know each other and were not working toward a common explicit goal. Fort Sill was solving the artillery coordination problem. Galvin Manufacturing was building a radio that soldiers could carry. The Signal Corps was determining how many radios to buy and where to assign them. None of these decisions was made with the Bocage of Normandy in mind, because none of the people making them knew that Normandy would exist as a theater of operations. They were making technical and organizational decisions based on the problems they could see from where they were standing, and the problems they saw happen to combine, in the summer of '44, into a system the German army could neither replicate nor counter. There is one more piece of the story that belongs in the record, because it connects the technical and organizational decisions to the broader question of why one army builds one kind of capability and another army builds a different kind. The German army, in the years before the war, was not unaware that American radio production was outpacing German radio production. German military intelligence had a reasonable picture of American Signal Corps procurement, of the scale of the American communications manufacturing industry, and of the doctrinal directions that American military publications were describing in the late 1930s. The German military assessment of American military capability in that period consistently rated American tactical ability as limited and American equipment quality as industrial rather than sophisticated. The assessment was not entirely wrong. American infantry tactics in the early years of the war were, in several theaters, less effective than German infantry tactics at the unit level. American equipment was manufactured in enormous quantities with good reliability, but without always achieving the peak engineering performance that German military equipment programs aimed for. The assessment missed the point, in the way that assessments built on the wrong framework always miss the point. The question was not whether American equipment was individually superior to German equipment. The question was whether the combination of equipment, doctrine, and industrial production that the American Army had assembled would be able to deliver effects on the battlefield faster and more reliably than the combination the German Army had assembled. And that question had a different answer from the one the German assessment had produced. The German assessment had been built on the framework of the German military tradition, which evaluated military capability in terms of individual unit quality, tactical skill, and the initiative and judgment of individual commanders. By those measures, the American military was genuinely inferior to the German military for much of the war, at the level of the individual soldier and the individual tactical unit. The German assessment was correct within its own framework. What the framework did not account for was the possibility that industrial-scale organization, applied to the fire support chain, could substitute for tactical skill at the unit level by delivering fire on a timescale that made the skill of the individual German soldier less relevant to the outcome. You did not have to be a better soldier than the man in the hedgerow if you could put artillery on his position before his mortar section had a chance to engage you. The German system was designed to make the individual soldier difficult to kill. The American system was designed to make the question of killing him fast enough that his difficulty in being killed became a secondary consideration. This is the structural verdict that the interrogation reports, taken together across the summer and autumn of '44, point toward. The German soldiers who died in the Bocage and in the approaches to the Siegfried Line and at the Rhine crossings were not killed by a superior enemy in the tactical sense they had been trained to understand superiority. Many of them were tactically superior to the Americans who were advancing against them. They were killed by a system that treated their tactical superiority as a problem to be routed around rather than overcome, that located their positions by prediction and map analysis rather than by direct observation, that called fire on those positions before they had a chance to exercise the tactical skill that might have saved them, and that did all of this with a radio that weighed 5 pounds and fit in one hand and had a range of 1 mile and was operated by a first or second lieutenant, who had been trained at a replacement depot to use it in 6 weeks. The Oberleutnant with a bandaged arm understood, by the time he sat in the interrogation tent, that what had destroyed his company was not bad luck or bad positioning or inadequate tactical skill. He had done everything correctly. What he had not known, and what his training had not prepared him to know, was that correctness, in the framework he had been given, was no longer sufficient. The framework had been built for a battlefield where observation preceded fire, and where the chain of command was the appropriate and adequate routing mechanism for fire support requests. The battlefield he had found himself on was built on different assumptions, and the different assumptions had been embedded in a 5-pound radio that sat in every American rifle platoon headquarters and connected the man who saw the target to the system that could act on what he saw before the runner, carrying the German request, had covered half the distance to the battalion command post. The clearest window into the psychological dimension of this experience comes from a set of interrogation reports that the 1st Army G2 section compiled in the autumn of '44 and forwarded as part of a combat lesson summary to the European theater headquarters. The summary describes, across multiple prisoner accounts, a consistent and specific form of disorientation that German infantry experienced after extended periods of fighting against the American artillery system. The prisoners did not describe fear of artillery in the way that soldiers from other theaters had described it. The American Army had built a chain, connected by radio from the man in the mud to the guns behind him, and that chain was what could not be explained by any framework that stopped at the hedgerow. The story of how the American system was built, and why the German Army could not have built the same system, even given the knowledge that such a system existed, runs deeper than a comparison of radio sets and organizational tables. It runs into the question of what an army is and what an army is designed to produce, and the answer to that question is not the same for both armies. The German military tradition, as it had evolved from the wars of the 19th century through the experience of 1914 to 18 and into the interwar period, had been built around a specific theory of what produced military effectiveness. The theory held that the decisive element in battle was the quality of individual military judgment, exercised by trained officers at every level, acting on their understanding of a situation that was always changing faster than any communication system could track. The ideal German officer was not a man who waited for orders and executed them with precision. He was a man who understood what his commander intended, assessed the immediate situation with the trained eye of a professional, and acted in a way that served the intent, even if it violated the specific instruction. He was, in the language the tradition had developed, to function at 2 levels above his assigned rank, meaning a platoon leader was to think and decide the way a company commander would, and a company commander was to think and decide the way a battalion commander would. This was not a preference. It was a professional standard that the Army evaluated and promoted against. The consequence of this tradition for communication was profound and not always visible from the outside. The German officer was not supposed to ask for permission. He was supposed to act. If he needed to request supporting fire, he did so through the chain of command because that was the correct procedure, but the chain of command existed to coordinate his action with the actions of adjacent units, not to authorize or supervise his judgment. The melder who carried his requests was not a symbol of inadequate communication technology. He was appropriate to the command philosophy. The command philosophy assumed that the officer in the forward position would act on his own judgment in the first critical minutes of any engagement, using the resources he had directly available, and that supporting resources requested through the chain would arrive in time to influence the second and third phase of the action. The assumption was usually correct. What it was not correct for was a situation in which the critical first minutes of an American engagement were already being shaped by artillery, called by an observer who was forward, with the infantry, connected by radio to a system that had been specifically designed to respond in those first minutes. The American military tradition had taken a different path toward military effectiveness, one that was shaped by the particular character of the American industrial economy and by the specific lessons that American officers had drawn from the experience of the Great War. The lesson American artillerists drew from 1914 to 18 was not that better individual judgment was the answer. The lesson was that the relationship between observation and fire delivery was a systems engineering problem, and that systems engineering problems were solved by designing better systems, not by training better individual soldiers. The Fire Direction Center was the product of this approach. It was a procedure, and then a place, and then an organizational structure that had been designed to make the aggregate output of multiple artillery batteries greater than the sum of their individual capabilities by centralizing the computation and distributing the execution. It was, in its fundamental character, a manufacturing floor for artillery fire, with the forward observer as the order input and the gun line as the output, and the fire direction center as the production control function in between. This way of thinking about military effectiveness was native to an economy that had spent 50 years building assembly lines. The Ford Motor Company's River Rouge complex, which was producing a complete automobile from raw materials in 81 hours by the early 1920s, was not just a factory. It was a proof of concept for a way of organizing the relationship between inputs and outputs that the American military had absorbed without necessarily being aware of absorbing it. The Fire Direction Center worked on the same principle: standardize the inputs, centralize the processing, distribute the outputs, and the system performs reliably and at scale regardless of the skill variation among the individual operators. You did not need a brilliant forward observer to make the American artillery system work. You needed a competent forward observer with a radio and a standardized call procedure. The system did the rest. The German artillery system required the opposite. It required that the individual officers and non-commissioned officers at every link in the chain exercise good judgment under pressure, because the chain itself had no redundancy, no alternative routing, no fallback if the person at any link was unavailable or wrong. When the company commander was killed and his replacement did not know the current fire plan, the artillery support degraded to what the new commander could improvise. When the telephone wire was cut and the runner was slow, the artillery support arrived late or not at all. The system was only as good as its weakest link at any given moment. They described a particular kind of uncertainty that went beyond the physical danger of shellfire. They had been trained to read a battlefield, to assess where the danger was, and to position themselves to minimize exposure to it. Their training had been tested in multiple theaters and had generally worked. In Normandy, it stopped working in a specific and puzzling way. The position that was correctly chosen by every measure of their training, the position that was genuinely hard for the American infantry to see, was still hit. The position they had occupied at night and improved during the hours of darkness, the position that had no sign of recent movement, was hit before the American infantry had any reason to know it existed. The shells arrived not because someone had seen them, but because someone had thought about where they would be. This is the thing the interrogation records keep returning to in different words. The German infantry had been trained to defeat observation. Their camouflage was designed to defeat observation. Their fire discipline was designed to defeat observation. Their position selection was designed to minimize the chance of observation. And the American fire kept arriving on positions that had not been observed, that by every measure the German soldiers could apply should not have been known to the enemy. The experience was not just dangerous. It was epistemologically disorienting. The rules of the game they had been trained to play had been changed without announcement. The American forward observer who was calling fire on unobserved positions was not working magic. He was working from a map and a set of terrain analysis skills that the Fort Sill curriculum had been developing since the 1920s, skills that allowed an observer to look at a contour map and identify with reasonable probability where an experienced infantry platoon defending that terrain would put its mortar section and its reserve element, based on what the ground offered in terms of cover, fields of fire, and withdrawal routes. He was treating the German platoon as a rational actor in a terrain, and the terrain constrained the rational choices available. When he called fire on those likely positions in the first minutes of an engagement, before direct observation was possible, he was betting that the German infantry would have done what any experienced infantry would do with that terrain, and the bet was usually right. The radio let him place the bet immediately. The 5 to 7 minute response time let the bet pay off before the German position had a chance to relocate. It is worth being precise about what this was and what it was not. It was not a new technique of war that the American army had invented from whole cloth. Predicted fire on likely positions was not an American invention, and the German artillery had employed it in many situations. What was new was the speed and the level at which it was being practiced. An American rifle platoon leader, a lieutenant who had been in the army for perhaps 2 years and in combat for perhaps 2 months, was able to call predicted fire on his own initiative in the first minutes of an engagement without requesting authorization from anyone above him, using a radio he could carry in one hand. The combination of speed, authority, and physical equipment was what no other army had assembled at the platoon level. The technique was not new. The architecture that made the technique available to a 22-year-old lieutenant in a Norman hedge row in June of 1944 was new, and it was the product of 15 years of decisions at Fort Sill and in the Signal Corps procurement offices that nobody at the time had announced as preparation for a decisive advantage. The German officers who survived the war and wrote their memoirs in the years that followed, in the camps and the occupation zones, and eventually in the rebuilt Germany of the 1950s, often described American material superiority as the dominant factor in the Western campaign. They meant ammunition, vehicles, aircraft, fuel. They were not wrong. What they described less often, because it was harder to see and harder to name, was the communication architecture that made the material effective at the speed and the level at which it became decisive. The ammunition was important. The radio that allowed a platoon leader to call for the ammunition within minutes of identifying a target was the mechanism that turned the ammunition into a battlefield advantage that the German chain of command could not match on the same time scale. There is a final observation worth making, one that the interrogation records do not state explicitly, but that is implicit in the pattern they described. The German officers who sat in the interrogation tents and tried to explain to their American questioners what they could not explain were not describing a failure of German military science or German military courage. They were describing the consequences of two armies having made different organizational bets about where to put the critical capability that turned observation into fire. The German army had bet on the chain of command, on the experienced officer's judgment, on the integrity of the communication links that ran through that chain. The American army had bet on the forward node, on the junior officer with the radio, on the system that was designed to respond to his call rather than to route his call through a structure that added time at every step. Both bets were irrational, given the traditions and the resources and the doctrinal frameworks that each army had inherited. One bet produced a fire support response time measured in minutes. The other produced a fire support response time measured in tens of minutes. In a Bocage where every engagement was decided in the first 10 minutes, the difference between those two measurements was the difference between a right platoon that survived to influence the battle and a right platoon that ceased to exist before the battalion had been told there was a problem. The Oberleutnant had done his job correctly. The system he was fighting inside had not been built for the system he was fighting against. Thank you for staying with this until the end. If what you heard here stayed with you, the other films on your screen carry the story forward. Subscribe if you have not, and I will see you in the next one.